Welcome to all nodes explained in Unity Shader Graph. In this video I will introduce you to all the nodes and will give some examples. You can find all the time codes in the top comment. I will go top down from the Create Node menu and I will explain everything. Let's start with artistic adjustments. In the channel mixer you can mix color channels if your input is a color, a texture or something like that. With the contrast node you can set the contrast of your texture. In the hue node you can set the hue. Make sure that your range is normalized, then it will work better. In the invert colors node you can invert some colors, you just check them here. In the replace color node you can input a texture. You say which color you want to replace, for example green, and which color should be the result, in this case red. You can set the range, for example here, a good range, a little bit of fuzziness so that the replacement is a little bit more subtle, and this is how you go. In the saturation node you just set the saturation of your image. For example, if you want a black and white texture or material, just type in 0. In the white balance node you can just set the white balance, for example the temperature. If you want to have a hot material, say 1, otherwise 0, and in tint you can really tint this. Next up, the artistic blend nodes. Here you can blend between two different inputs. For example, this image and this image. 0 is this image, 1 is the other one. And the blend mode is not that you have the other one in here. You can really specify how you want to blend. If you know Photoshop already, you see that these are very similar options you have in the layers. For example, you can set hard light and then you can slowly blend in the other image. So, or for example, override should really override the image completely. Artistic dither just adds dither to your image. With artistic mask you can create mask. For example, a mask for green. Just let the green checkbox, the only checkbox, and then you have a green mask. Or you can have a color mask. If you, for example, want to mask every green pixel in your image, just choose green. I don't have the exact pixel color like this one, so I can set the range a little bit higher. And you see you have a mask which you can use for your further workflow. You can set the fuzziness to have some gradients from one color to the other. Artistic normal is all about normal maps. I have two more normal maps here, a brick wall and this primitives normal map, and you can blend them together with normal blend. Then both are applied at the same time. You can create normal maps by using the node normal from height. I put in this image, a Voronoi diagram. It will generate a normal map for you from this black and white image. You can create a normal map from a texture. I used this texture, this is the output. Now I have a normal map. If your Z value in your normal map is broken somehow, you can put in X and Y values and that one will be calculated. I don't know in which cases this could be useful, so just because I explain every node, and I think this is the most useless node because I don't know where you can use it. It's in here, so let's go on. Normal strengths can be used to strengthen up your normal map or weaken it. For example, if you type in 0, the strength is 0, and you can go slowly up to 1, where your normal map is as it is in the input, or you strengthen it even more. Normal unpack is a pretty useless node, and it's also written in the Unity documentary that this shouldn't be used anymore, or it's not necessary to use them. It's just if you have a texture and you have the type default, you can unpack it to make it a normal. Otherwise you could just say, okay, I imported it directly as a normal map, then you do not need this. If you do this twice, weird things can happen, so make sure that your setup is always correct. In artistic utility, you can do a color space conversion. This is extremely helpful if you split your color. For example, all the black parts here all the white parts here are red, all the green parts are white here, and all the blue parts are white here. If you have, for example, a white ball, this means you have full red, full green, full blue, and this is in result a white color. But sometimes you want to, for example, have the hue saturation and the value, and then you, for example, get out here a black and white image. This can be helpful in some workflows. The channel nodes are all about splitting values, accessing values, and merge them together. For example, the split and combine nodes are in here. The split just takes any vector, for example here a vector 4. It does not need to be a sample texture or texture in general. It can also be a position. It splits up this texture, and you see here everything that is stored in the texture, and you can combine it back together. So in this way you can access single attributes. With a flip node you can flip some colors if you want, and with a swivel node you can change the order of the vector. For example, you get in RGB alpha, you can set okay, red is red now, green is now green, and blue is alpha, and alpha is blue, and then you switch those two. If you use the swivel node, just connect your texture in here, save your asset, close your asset, and open it again because it's some kind of buggy. Let's continue and go to the input nodes. The boolean is just a boolean. You can use a branch to just differentiate between two different inputs, for example 1 and 0. If the boolean is checked, the result is true, and otherwise it's false, and this is the output. The color is self-explanatory. It's just a color. The constant is a constant. Here are 5 constants that you can use, for example pi. The integer is the integer. It's there because you can input a vector 1 and then define it as a slider or integer. That's the reason why the slider is also there. An integer, a slider, and a vector 1 is basically the same. The output is just a vector 1. The time node just gives you some access to the time. The time is the time since start. The sine time is just the time, and it's applied to sine. The same goes for cosine. Delta time is the delta between two different frames, and the smooth delta is the time between two different frames. But if you do not have a very stable frame rate, the smooth delta is a little bit smoother. Vector 1, 2, 3 and 4 should be clear. You can directly type the numbers in. Input geometry gives you some access to the geometry, for example the tangent vector or the normal vector of your vertex or the position of your vertex. These values directly come out of the file you are importing from the mesh. The screen position is the position of the vertex on the screen. The tangent vector is the vector of the tangent. The UV is a UV from the input mesh. The vertex color is the default color defined in your mesh. The view direction is the direction of the camera. Let's go to gradients. So there are 2 different nodes, and normally you connect them together. You have a gradient out, and there is only one node where the gradient can go in, a sample gradient. And with this x value you can iterate through it. For example here, black, blue and white. 0 is black, 0.5 is blue, and 1 is white, and you can smoothly iterate through it. With input lighting you have access to all the lighting settings you have set up in your Unity lighting tab. For example, the color, sky, equator or ground. These are the ambient settings. Everything you have baked into the global illumination or the reflection probe. In input matrix, you can create matrices, for example 2.2, 3.3, 4.4. You can use them to create determinants, or just multiply them with vectors and you get a vector out, which you can use for colors or something like that. A transformation matrix is a matrix generated from the model, the view, the projection, or something like that. Dialectic, specular are some materials that are predefined, for example rusted metal, water, ice, glass, or custom. Or metal reflectance are metals that are predefined. You can have a look at the help. Just place the mouse cursor over the node, right click, open documentation. It says how you can use it. For example, you need in the PBR master the workflow for metallic, and then you can set the metallic reflectance to the albedo. Input scene, you have access to the camera position, the camera direction, orthographic, and so on. The width of the camera, the height of the camera, the values of the fork you have set up in the Unity editor, the object itself. So this position differs from the position. The main difference is that this is the origin position of the object, and this position is the position of the vertex that's just being processed by the GPU right now. The scene color is the color you set up in the Unity editor. It's the same as the scene depth. You set it up and you can exit it here. The screen width and height is also accessible. The input texture nodes are always coming in a pair. For example, the cube map has a cube map asset and a sample cube map, and you have to connect them. The same goes for the texture 2D asset and the sample texture 2D. You always have to connect them because you can only plug in those RGBR outputs into the PBR master. The texture 2D array asset is basically the same as the texture 2D asset. The fact that you have another input node helps you just accessing one element of the array. The same goes for the 3D asset, it's just a 3D texture. The sampler state helps you importing your texture. These are also in the importing settings, but you can override them here. So here I have an example texture, a little bit tiled and offset, and for example if I use a trilinear filter, I guess you won't see it because it's too small here, but it gets blurred out on the edges. I can choose the web mode as well. For example, if I say mirror, this whole texture will be mirrored, or I say clamp, then only one texture is applied and the edges are stretched out. The texel size gives you the possibility to access the resolution, for example the width and the height of the input image. And that's all we got for input. Let's go to master. Master gives you access to PBR and unlit. This master node is always created from start. If you have a look at the asset folder and you create a shader graph, you have to choose if you want to have an unlit shader or a master shader. It doesn't matter, you can also use an unlit shader, delete the master, create a PBR master, and then you have a PBR shader. The basic difference between those two is that the PBR stands for physically based rendering. These are the input for the actual rendering, and the unlit master is an unlit material. It means it's not affected by light, and that's why it just has the color. And the other one and the PBR are just there to calculate the right color based on the lighting that will affect the material. I don't want to waste your time. Next up, Math Advanced. Absolute value just removes the sign if there is any. The absolute value of -2 is 2, the absolute value of 2 is 2. Exponential, you can choose a base, for example base 2. If you have 2 to the exponential base of 2, you get 4. So this is the input and this is the exponential value. Exponential, you choose a base and you get the exponent as an input. Here is the input, x, 2 to the x equals, for example, 4 if x equals 2. this is exponential. The length is the length of a vector. Simple as that, you put in a vector, you get out the length. You can put any vector in. If you put a vector 1 in, you get it 1-to-1 out. Logarithmic values, you can choose the base, for example base 2. Base 2 means the logarithmic function. And here is the input. And for example for 4 you get 2. That's it. Modulo. Modulo is simple, so for example it's the rest of the division, so 4.5 modulo 5 equals 2.5. And the thing is, if you have I modulo something and you iterate over that I, everything repeats all over again as soon as I is increasing. And you can use it, for example, for colors. Here is a Voronoi diagram, here's a modular, and you get the same gradient all over again, so you can create cool effects with it. Negate, you just take the negative of the input, and for example if I negate this 0 to 1 Voronoi diagram, I got -1 to 0, and if I add 1 I get the negative of this picture here. Normalize, normalize is for normalizing vectors. After that, the vector that comes out always have a length of 1. Posterize, posterize is nearly the same as a modular here. You put in a vector or something like a picture, and you have a step definition, and the amount of steps is the amount used in the picture, so you can have really steps, and there's no gradient anymore, just steps, and you can define how many steps you want. Reciprocal. Reciprocal is just a short form for divide. So the first one is 1, and this is the input. It doesn't matter if I change it here or here, it's just a shortcut for it. And reciprocal square root is the same as before, so here is the 1 divided by the square root of the input. This is the only difference. You can use this node or those two, it doesn't matter. Basic math, so you can just add things and subtract things, which is really 1 + 1 = 2. You can do this for colors as well. If you add something, the color gets brighter. If you subtract something, it gets darker. The same goes for division. If you divide it, it gets darker. You can multiply vectors. You can multiply matrices with vectors. You can multiply single numbers and of course colors. For example, the 1 is a white value here. If you multiply this by a red, you get this output here. The power is easy as it is. For example, here I put it in a 0 and a 2. It's 0 to the 2, and the result is 0. The square root is really the square root. I do not have to explain it, I guess. And derivate. Yes, you can derivate something. I don't know why you should do this, but it's possible. So you will get something like the value or the steepness in this point. If you have a function, you can derivate by x or x and y or just y, and the input is always some kind of position in the word space or object space. Interpolate. This is the most used function in the complete shader graph. Most of the time you want to interpolate between two images or vectors on something like that. I've used the slider as a t-value. If I use 1, I get the checkerboard down here. If I use 0, I get the Voronoi diagram, and I can interpolate between those values. The inverse linear interpolation does the same thing, but just reverse it. So it will calculate this t-value. Black is 0 and 1 is white, so you can reverse it if you want. The smooth step is like the step, and you can define edges here so that you just get a part of it, or you want to have a step at a specific position. If the first edge and the second edge has the same value, it's just the same as if you would use a step node. Math matrix, we know the matrix already from the input, so you can construct the matrix. You can use the input matrix node as well. It's basically the same. You type in all your values you need, and you have some functions. For example, you can calculate the determinant. You can split the matrix in the components you want, or you can transpose it. Ranges, very simple concept. So you put in a min and a max value. If you are above the max value, the output is the max value. If you are below the min value, the output will be the min value. If you are in between, the output is just the input. The fraction node just calculates the fraction. For example, for this number 1.26, the output will be 0.26. Just everything after the dot will be outputted. Minimum and maximum just outputs the minimum or the maximum of the input. 1 minus can also be created by just subtract 1 minus an input. This is just an abbreviation node because it's used so often. Random range creates a random number between the minimum and the maximum value based on the seed. Remap just normalizes your input. So you have an in min max and an out min max. For example, my in min max is -1 to 1. I expect the input in this range, for example 0, lies exactly between -1 and 1. And then it's mapped between the middle of 0 and 10. So here it will be, I guess, somewhere around 5. If I type in 1, it will be mapped to 10. If I type in -1, it will be mapped to 0. So, and if I type in 0.5, this means that it's mapped to 7.5. So it just normalizes the input and multiplies this with the range of the output. The separate node is again an abbreviation for a more complex input structure. So it's basically a clamp node with min value 0 and max value 1. So they are cut out here and you have just the input. So these two nodes do basically exactly the same. Math round does the rounding for you. So you can round up with ceiling, round down with floor, round at 0.5. This is a node round. Or you can get a sign. The sign will output 1 or -1. If the input is bigger than 0, the output is 1. If the input is smaller than 0, the output is -1. The step node is just like a smooth step. It's an abbreviation where both inputs are the same. So you just define the number where the threshold is, where the cut between 1 and 0 should be made. You see the Voronoi diagram on the left. And if I choose a very small value, only the dot here is selected. If I select a very large value, only the very white spots are white here. Every calculator has this, and Unity has this too. The trigonometry functions, the sine, cosine, tangent, and of course the sister function as well, the arc and the hyperbolic. And you can also convert, for example, degrees to radians and radians to degrees. Math vector, you can calculate the distance of the vector, the dot product and the cross product. Normally the distance or dot product does not make sense with vector 1, but these are the defaults here. You can also plug in vector 2, vector 4, vector 3 just to calculate these values. The Fresnel effect is a little bit more complicated in the computation, but for the usage it's very easy. You just have a power and the edges of your object will have a different color than the center, because this is what happens in real nature. The edges are a little bit lighter. If you look at a very flat angle on objects, you will see that they are a little bit lighter, so you can use the Fresnel node to create the Fresnel effect. So the sphere mask is used in 3D space, therefore I can't give you an example, but imagine the following situation. You have a cube, a basic cube in 3D space, and then you can define a center where you want. So the center is the input. You can, for example, take the origin of an object. I will, for example, use here the bottom of this box, and then there will be spheres around the center, and if it's above a radius it will be highlighted, for example here, and if it's below a radius it's not highlighted. And highlighted means the output of 1, and not highlighted is the output of 0, and you can use this to mask something out. And the hardness just creates a gradient around the sphere, so that in this hardness range there is not a 0 and 1, there is a slightly gradient. If you set the hardness to 0, you will have a hard gradient or no gradient at all. Rotate about axis is just the same as the C# function angle axis. You have an input vector and an axis, and you want to rotate around it, so either in radians or degrees. The unit can be set up here. Reflection and projection helps you with vector 3s. So you define a normal, maybe the normal is just going up. This means the surface is flat on the ground. And then you have an input vector for the reflection, which directly points to the ground, and the output is this vector, which is just mirrored around this up vector. The projection works a little bit different. So you have one vector and you project it to another vector, and then a 90 degrees angle is taken here, and here this dotted line will just project this point to this plane or vector, and this is here the output you will get. It's like the sun which is casting rays. This is nice for calculating shadows or other things. Transform, do not mess up with the theta transform class. It's a little bit different. Here you really transform positions. For example, the position of an object to the position in the world. So for example, if you have a point that's exactly at your origin of the object, it will have the value 0, 0, 0. If you want to know where this point in the world is, you can convert this with this node. The last things in the math category are waves. Normally the input are time nodes or just coordinates. So you can specify a sine wave, which is just a wave between the maximum number and the minimum number. If you have the sawtooth wave, you have a structure like this, and it's between 1 in maximum and 0 at the bottom. The square wave looks something like this. These are just steps between 0 and 1. And the triangle wave is just a triangle. It goes up slowly and then falls down immediately. You see here how slowly it goes into a white value and then directly drops to black. Next section, procedural. These are very good procedural things. I hope they will add more in the future because they help with prototyping. You have a checkerboard at the first position. You can set the colors how you want them, and you can set the frequency as high as you want. You have some noise options. The Voronoi noise, I used it a lot in this video. You already seen it. You can also have a gradient noise with a scale and a simple noise with a scale. Shapes, you have some basic mathematical shapes you can specify with height and so on, radiuses, sides, and many more things. Or a rounded rectangle, you can use them, for example, for masking out things. Here I have two different textures and I want to merge them in my material, so I take a linear interpolation, and then I can specify the radius or the height and the width, and this is very fast to set up and very useful. Utilities. So there is the preview node. You can just plug anything in it and it will show this preview, It only shows colors. Unfortunately, it does not show any vector 3 values, or you have to guess them by the color, but it's pretty hard. Logic is just a Boolean logic. You have all the operators you need, and or not, and you can create them by input vectors, for example asking, is it infinite, yes or no, is it not a number, is it the font face. If you want to use this, you have to go to the PBR master and say, okay, I want to have a two-sided render. And if you just render the back face, you can, for example, use a different color or do something like that. And you can also ask for if any of these numbers or inputs is 1 or all of the inputs is 1. And you have a comparison node. You can compare two vectors or two simple numbers if they are equal, not equal, less, greater, or something like that. And the result of all the logic here is nearly in every case a branch where you put in a predicate and then you say, okay, it takes the input from the first one if the predicate is true, otherwise take it from the other one if the predicate is not true, and you see I'm switching between those two noises here. The last section is UV. And the first thing you can choose is a flipbook. If you have a texture like this, you can specify I have 4 different rows and 8 different columns in my texture, and then you can choose a tile, for example tile 0, 1, 2, 3, 4. You can do animations with it or anything like that. Make sure to use this pattern and type in the right numbers, otherwise you will get some nasty results. Polar coordinates, you can choose a scale and the length. I don't know right now where is it useful for, but maybe in the future I will see someone using this in a brilliant way and I can directly report it to you. The radical sphere is just a little bit different, and you can choose how the strength is and the offset, and it will create some kind of a invisible sphere over your texture and just manipulate the UV values. You can also rotate your input picture, for example if it's upside down or something like that. You can rotate it as you want. You can set the center where you want it to be and then rotate around it. Sphereize, just creating a sphere, and you can set everything you want to create a sphere effect, and in the middle the UV coordinates are stretched out and at the corner they are nearly the same. Tiling and offset, most often used, I guess. The tiling just says, okay, how many tiles do I want to see and how many tiles do I want to see in the other direction, and the offset just sets the offset of the image. Twirl is another interesting effect. I used the twirl effect in my shader graph fish tutorial. You can just twirl the complete thing around, and you can set the strength, the offset, and the center. The triplanar is a little bit different. It's a little bit more complex to explain, therefore I grabbed the main preview. Here you see a sphere, and no matter how I rotate the sphere, the texture is always oriented on the view. If I look close to it or directly on it, I see my texture because it's projected from the view, from the front, from above. You can't see it, so here you see a little bit of it, and from the left or the right, so the sides. And if I rotate it, then it's merged together here in a way that half of the upper projection is visible and the other projection from the front. That's it. These are all the nodes in Shader Graph. Most of the nodes are pretty simple and easy to understand. The real magic is in the usage, and therefore you have to look up a lot of examples. Every example that you get in your hands, take a deep look at it, because everything in shader graph is about the connection between those nodes. The node itself are very simple. This video should help you to just motivate you to try out new nodes. If you like the video, please leave a like and comment something that I did wrong. I don't know if I get everything right here, but I still did my best. So see you next time. Subscribe to my channel to get more straight to the point tutorials.